Hey everyone, welcome to my video on center of mass with 2D point mass systems, and we're going to be looking at 2D point masses as well as composite shapes in this video. So the first thing I want to do is just kind of remind you of what we did with 1D. So remember, we would put a mass somewhere. Let's say we had a mass like here that was mass of 5, and that's 3 units out, so 1, 2, 3 units out, which meant the moment would be that 5 times this distance 3 that's coming out this way. So 5 times 3 would give us 15 for that moment. And then with the 1D, if you think of maybe just being along this central axis here, we would just try to place either one or more masses so that the moments would equal. So 15 on the right, 15 on the left. Usually we use positive and negative distances for those moments. What we want to think about with 2D is that rather than balancing on a single point with just one dimension, now we have 2 dimensions that we can go in, but maybe balancing on an axis to start out. So if we're balancing this plane on this axis, we can think of this maybe as the y-axis right here. Where would I need to put some points so that this would balance? And the idea is going to be the same. I want the moments around this axis to be the same as the moments on this side. So we're still going to do mass times distance. But this time, maybe I could do something like this. I might put, say, 2 units away, maybe a mass of 5. So maybe right here, I could put a mass of 5, and that distance is going to be a little bit straighter. That distance is going to be 2. So this would be a moment of 10. And now we still need another moment of 5 to balance out, but I don't have to necessarily put it here. See, it doesn't really matter where I'm at in the y direction because we're solidly planted on that balance beam that's right there. So nothing's going to move, say, side to side this way across the x-axis or anything. It's only going to tip in this direction. So you're only looking at tipping with respect to being around this y-axis. So it doesn't really matter how far up or down these points are. It just matters how far they are from that axis. So I might put another 5, maybe 1 away. Maybe I'll go, say, here. It doesn't really matter. You could go here, 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 anywhere, as long as it's just 1 unit away from that axis if the mass is 5. So the moment of this one would be 5. So we got a moment of 10. Moment here is 5. So total, this is going to be, these would actually be maybe negative 5, negative 10. So total moment on this side, negative 15, moment on this side, positive 15. So that's kind of the idea that we're going to take in these next examples and just see where we might want to place things, and then again compute a center of mass for these guys. Alright, so if we look at this first problem, it kind of mirrors what we just did. Where could I place 3 stacks of bricks? And those stacks could be of any height, so maybe 10 bricks in a stack, maybe 2 bricks in a stack, but just 3 stacks, so the plane is balanced. And then we're going to draw this scenario below. So balanced on the y-axis for this one, we could put, say, a mass of 3, and stay right here. So that's going to be 3. And since we're balancing on the y-axis, this is 1 unit away right here. Maybe we want to do another stack up here. Let's say this is 4 right there. That distance is 3 away. So far we have moment here is negative 12. The moment down here is 3 times 1, so positive 3. So we need a positive 9 somewhere. So we could go 9 1 unit away, we could go 3 units away. It really doesn't matter what you want to do as long as it's 9. So I'm going to go ahead and just say, let's go way down here and just say 3 units away, I'm going to put a mass of 3. Alright, so it's going to go right there, and that moment would be 9. Alright, so we got 3 times 3 for that one. So on this side of the y-axis we got 12, on this side we got negative 12, so moments will cancel out to 0, and that should balance the system. If you want to balance on the x-axis, you can do something similar. So 3 stacks, again, let's just say we're going to put right here, maybe 5. So that's going to be 2 units away from the x-axis. So far there we got a moment that is 10. Maybe we'll put, say over here, maybe 5 units down, we'll put 1 brick. So there's my 1. So this is going to be a moment of negative 5. And then we just need 5 somewhere else. So again, I could put 1 5 away, or I could put 1 5 away, 5 1 away. It doesn't really matter on this one where you go. So maybe we'll put it right here on the y-axis. So I don't need to place any on the x-axis. That's not going to count for anything. So maybe we'll just put 5 right there on this one. 1 unit away, so a moment there is, again, negative 5. So this gives us 10 here, negative 10 on this side. The important thing is, right, this doesn't really have to balance left to right. We're just concerned about top to bottom. How does it balance across this x-axis? And over here, balancing on the y-axis, it really doesn't matter where you're at vertically. It just matters how far am I horizontally, how's it going to balance across that axis right there. So you're just looking at that left to right distance. Alright, so what rule would you make for, or would you state for making sure the system stays balanced around the y-axis? So around the y-axis, you would want to make sure, right, your moments left to right are going to be the same, and your moments top to bottom are going to be the same for the x-axis. So you can go ahead and put that down. Now before we do the next part, we're going to make some definitions. So we're going to look at center of mass again, just like we did the last one. But this time we need moments with respect to the x-axis. So this definition, notice, has a y in it. With respect to the x-axis, that's just because I'm taking these y distances, right? So I want the mass times this y distance right here, which we're just denoting as this yi. How far is it from the x-axis? Going to be a distance y. Same thing, moment about a system with respect to the y-axis. This is the mass times how far am I from the y-axis. So that's going to be a distance x. What does get people confused sometimes are these symbols right here. The my is named after the axis, so y-axis, that's right there. And that's not to be confused with mass times y. It's mass times distance from the y-axis, which happens to be an x. So don't let the my being defined in terms of x mess you up. It does help if you kind of draw it out and think about it as respect for this left side. Shorthand is named after the axis, and the corresponding symbol on the other side is different because you're going away from that axis. So just one thing I wanted to point out for those two definitions of the moments. Mass is easy. You're just adding up all the masses, get the total mass. And then center of mass, just like before, we're going to divide those moments by the mass. Again here, make a special note, this is my, which was defined because of these x distances. So x distances go with what we often output is this X bar right here, and this definition with the lowercase x moment with respect to the x-axis are dealing with these y's that are right here. So right there we get the y bar. Right. So again, these are named for the axis, but the distances themselves are y distances. They go with the y bar. X distances, they go with the x bar. All right. So that kind of answered that question right there. Let's go ahead and do a couple point mass problems and see what we get for just finding the center of mass. So we got this right here, 2, -1. We get a mass of 6. So we want to put these guys right here. So there's a 6. The 3, 4, that's going to be 3 right there. -1, -2. And this will be a 4 down here. And then -3, 2, that's going to be a 5 right there. So those are the masses. And then we're going to look at distances for these guys. So if we want to find mx or my, let's actually do my first. So this is going to be, again, remember these distances from the y-axis. All right. And if you want to just look at the coordinates up here, you can, but it's 3 times 3 for the hexagon. So this x3 times the 3 right there. I'm going to say 3 times 3. For the triangle, that was this -3 times 5. So we'll say plus this -3 times 5. The circle, we got 4 times -1. So 4 times -1. And then the 6, we get a 6 times 2 for that square, so 6 times 2. We'll go ahead and add all those up. I'll do that in a second. So for that total, I get 2. Go ahead and do the same thing. mx, go ahead and use a different color for this one. This time we're going away from the x-axis, so these are going to go, how far am I from the x-axis? And again, if you just want to look at the coordinates, you can, but sometimes it helps to have a visual of what you're doing. So 3 times, this would be 4 away. So again, we'll kind of go in the same order. So 3 times 4, 5 times 2, 4 times -2, 6 times -1, that totals 8. And if we want the masses, that's not too bad. So we got 6 and 3, that's 9, 4 and 5, another 9. So total there, let's put down 6 plus 3, 4 and 5 would be 18 for that guy. And what you want to do for your x bar, right, is you're going to take this my and divide by the m. So the x bar, changed it to blue to match up with the calculation we did up here. We got 2 over 18. Again, these were x directions, so reduces to 1/9. The y bar, we got 8 over 18. Again, y directions, even though it's called mx, y directions, which gives us 4/9. So center of mass is going to be just that coordinate right there. So we got 1/9, 4/9. And if you want to plot that, you can. That should be over just a little bit up, not quite halfway. So probably somewhere around right there. Notice that is kind of in the middle of all these, but you do have to take into account not just the mass, but also the distance away as far as looking at those guys. And so here's another one you can try on your own in the worksheet. If you want to kind of post your answer to the forum, you can with that one. Next time, what we'll be looking at are these block shapes, and how can I do that? And it's going to be very similar to what we did with the points. So we'll talk about that in the next video.